So if I asked you right now where the future of artificial intelligence is being decided, what image immediately comes to mind?
I mean, for most people, it's probably, a sleek glass-walled office in Silicon Valley or something.
Right, exactly. Or maybe like a decentralized team of coders just huddled around laptops, endlessly tweaking the parameters of some massive new large language model.
Yeah, because we interact with AI entirely through software, right?
Mhm.
Through text boxes and voice assistants. So we naturally just assume the software layer is the ultimate battlefield.
Which makes sense on the surface. We view companies like OpenAI or Google or Anthropic as the architects of this whole new era.
But that assumption completely ignores the physical reality of how computation actually works, because software is really just a set of instructions.
Yeah.
And without the underlying physical hardware to execute those instructions at, well, incomprehensible speeds, the most advanced neural network in the world is essentially just a paperweight.
A very expensive paperweight. And so, okay, let's unpack this. Because in today's deep analysis, we're going to look at the entity that actually builds that physical reality.
Right.
Because the future of human intelligence, it isn't being decided in software. It is actually being dictated inside these ultra-clean, highly pressurized factory floors in Taiwan by a single monolithic company, TSMC.
Taiwan Semiconductor Manufacturing Company, yeah.
Yeah.
And it's wild because the world's biggest tech titans, Nvidia, Apple, AMD, Qualcomm, Broadcom, and even the cloud giants building custom silicon, they don't actually manufacture their most advanced chips.
Which is still crazy to think about.
It is. They just draw the blueprints. They design the architecture. They're what the industry calls fabless.
Right.
TSMC is basically the sole foundry capable of taking those incredibly complex blueprints and vestiging them into physical silicon at the absolute bleeding edge of physics.
Which sets up the core premise that we really need to get into today.
Mm.
You have all these massive tech giants fiercely competing for dominance, right?
Yeah.
But behind the scenes, they are all, well, they're trapped behind a single toll bridge.
Yep. Waiting in the exact same line.
Exactly. Negotiating with the exact same factory in Taiwan. So we're going to look at how access to physical silicon became the ultimate bottleneck for the entire AI race, and why the speed of technological progress is basically being rationed by one corporation.
What's fascinating here is that to understand the gravity of that toll bridge, you just have to look at the financial data coming out of TSMC. It provides the clearest picture of how the global industrial base is shifting.
Oh, the numbers are just staggering.
They really are. I mean, in May of the current year, TSMC reported a revenue print of roughly 416.98 billion new Taiwan dollars.
Oh, $8 billion.
Billion, with a B. That converts to about 13 billion US dollars in a single month.
Wow.
Yeah, which represents a 30% year-over-year increase.
And if you zoom out to the first quarter, they posted $35.9 billion in revenue. But, the sheer volume of money isn't even the most vital detail here.
Right, it's where the money is coming from.
Exactly. 61% of TSMC's total revenue now originates from their high-performance computing segment, or HPC.
Which is the category that houses the advanced AI engines and the data center chips.
Right. And that 61% figure, it effectively rewrites the company's entire identity. Because for years, the prevailing narrative tied TSMC primarily to smartphone upgrade cycles, right?
Oh, totally. They were the engine behind every new iPhone generation.
Yeah. And while they do still dominate that mobile space, the data definitively shows they are now the foundational factory floor of the AI revolution.
And that proves that AI is not just some fleeting consumer trend, It's not a hyped-up app ecosystem. It is a massive, multi-decade capital cycle that is heavily rooted in heavy industry.
A capital cycle that requires just compounding, staggering levels of physical investment. It's the classic pickaxe in a gold rush analogy, isn't it?
It really is the ultimate pickaxe, because developing a smarter chatbot requires training a larger model.
Yeah.
And training a larger model requires a massive new data center, which demands tens of thousands of highly specialized AI accelerators.
And manufacturing those accelerators requires bleeding-edge fabrication plants, or fabs.
Right. And those fabs require tens of billions of dollars, highly specialized chemical supply chains, massive power grids, and years of construction before a single silicon wafer is even processed.
So it completely insulates TSMC from the volatility of the software wars. Whether Nvidia maintains its hardware dominance or a massive cloud provider designs a custom in-house chip to replace Nvidia, TSMC still runs the manufacturing.
Exactly. They don't need to predict which AI application will win the consumer market. They own the industrial layer beneath all of them.
Right.
And that physical layer is vastly more complex to replicate than any software architecture. I mean, a tech company can push a code update overnight to pivot its strategy, right? You
Yeah.
absolutely cannot pivot a semiconductor fab.
But hold on, let me play devil's advocate here for a second. Because it's easy to look at those massive revenue numbers and assume TSMC just has like a temporary lead. We've seen tech monopolies fall before.
Sure.
I mean, look at companies like Intel. They practically invented the by 86 architecture. They ruled global computing for 3 decades.
Yeah.
And they have tens of billions in cash reserves.
Yeah.
Wait, so companies with practically infinite money like Intel and Samsung can't just spend their way to parity. What structurally broke inside their model that allowed TSMC to lap them so aggressively?
Well, the assumption that infinite money can buy manufacturing parity, it relies on a complete misunderstanding of what is actually happening inside a modern fab.
Okay, how so?
When we talk about cutting-edge chips moving from 5 nanometer to 3 nanometer and now designing 2 nanometer architecture, manufacturing basically ceases to be standard engineering. It becomes a brutal daily war against the fundamental laws of physics.
Just to put that scale into perspective for you listening, a single strand of human hair is roughly 80,000 to 100,000 nanometers wide.
Right.
And TSMC is manipulating matter at the 2 nanometer scale. It's like trying to bake a million-layer cake where a single grain of sand ruins the entire bakery.
That is a great analogy. Or like trying to print a functional map of New York City where the streets are the width of an atom. And if a single microscopic stoplight is drawn incorrectly on that atomic map, the entire city grid has to be bulldozed.
Wow.
Because at that submicroscopic level, standard manufacturing logic just collapses. Ambient heat causes materials to warp just enough to ruin the alignment of a transistor.
A single microscopic speck of dust acts like a massive boulder crashing through that atomic city grid.
Exactly. And to print these structures, TSMC uses extreme ultraviolet, or EUV, lithography.
Which sounds like sci-fi.
It basically is. This involves firing high-powered lasers at microscopic droplets of molten tin.
Wait, really? Molten tin?
Yes. 50,000 times a second.
That is insane.
It's wild. They do it to generate a specific wavelength of light that reflects off a series of flawless mirrors to etch patterns onto the silicon.
And performing that EUV process requires an environment so controlled that the slightest vibration from a nearby highway or a microscopic impurity in the millions of gallons of ultra-pure water pumped through the facility can introduce a defect.
Which brings us to arguably the most important word in the entire semiconductor industry: yield.
Right.
Yield is the structural dividing line between a profitable foundry and a financial black hole. It is simply the percentage of usable, fully functional chips you extract from a single silicon wafer after months of chemical processing and lithography.
So if you process a wafer containing 100 potential AI chips, but defects ruin 70 of them, your yield is 30%.
Right. And in advanced manufacturing, a low yield means you're essentially spending billions of dollars to manufacture scrap silicon.
So even if a competitor buys the exact same $200 million ASML lithography machines, their yield might be catastrophic compared to TSMC's fine-tuned processes.
Exactly. I mean, Samsung is pouring billions into challenging TSMC at the 3 nanometer node. Intel is executing this massive internal turnaround to rebuild its foundry business. They possess the capital and the equipment.
Right.
But TSMC's impenetrable moat is their ability to execute at scale repeatedly with incredibly high yields. They have spent decades refining these microscopic recipes, the exact temperatures, chemical mixtures, and timing that push yield percentages into highly profitable territory.
And from the perspective of a customer like Apple or Nvidia, gambling on an unproven yield is corporate suicide.
Oh, absolutely.
If you design a revolutionary new AI architecture, but your manufacturing partner suffers a yield crisis, your chip launch is delayed by a year.
And in the current AI race, being 6 months late means missing the entire cloud infrastructure roadmap. Your competitors secure the compute capacity, build the data center, train the next generation model, and lock in the enterprise contracts before your chip ever hits a server rack.
So the risk of leaving TSMC is simply too high?
Far too high. And that dependency grants TSMC absolute pricing power because demand is so much higher than supply, making these factory slots incredibly valuable.
Right. They are the sole reliable supplier of an asset that currently has effectively infinite demand.
Yeah. And under normal economic conditions, a company wielding that level of monopolistic control would institute violent overnight price gouging to maximize short-term profit.
But they don't do that. And,
Mm.
and here's where it gets really interesting. TSMC's CEO, C.C. Wei, operates under a philosophy of what they call disciplined monopoly management.
Right.
We aren't seeing massive, unpredictable price spikes that hold the tech industry hostage.
Yeah.
Instead, TSMC signals gradual, predictable price increases.
Yeah, they are turning advanced manufacturing into a gradually rising long-term toll system. Because violent price shocks trigger corporate panic.
Sure.
If TSMC suddenly tripled the cost of an AI wafer, companies like Nvidia, Amazon, and Google would instantly authorize unlimited budgets to fund Intel and Samsung out of sheer self-preservation.
Oh, without a doubt. So by keeping price increases measured and predictable, TSMC ensures their customers remain comfortable on the toll bridge.
Exactly. And Y's strategy justifies the rising costs by pointing directly to the required infrastructure build-out.
The message is very clear, right? They're
Yeah.
saying you want faster AI models, which means you need more capacity, which means we have to build new fabs. And new fabs cost upwards of $20 billion each.
And it goes beyond just printing the raw chips. We have to look at advanced packaging, which is becoming the real bottleneck in this whole capital cycle.
Oh, right. Because Moore's law, the traditional shrinking of transistors, is slowing down.
Exactly. So to keep increasing performance, companies can no longer just rely on smaller nodes. They have to physically stitch multiple chips together. You take a central logic processor and surround it with high bandwidth memory chips, integrating them on a single silicon interposer so they communicate instantly.
And TSMC calls their proprietary version of this COPOS, or chip on wafer on substrate. And right now, the entire AI industry is bottlenecked not just by making this silicon, but by TSMC's capacity to package these components together. Because building out CoWoS capacity requires massive, specialized factory space.
If we connect this to the bigger picture, it perfectly illustrates the inescapable feedback loop governing the tech sector right now. Massive demand from cloud providers funds TSMC's capacity expansion.
Right.
That new capacity, both in raw fabrication and advanced packaging, further solidifies TSMC's monopoly because no competitor can match their sheer output volume.
And that volume gives TSMC the steady revenue to fund the astronomical R&D required for the next generation of 2-nanometer chips, pulling them even further ahead of Intel and Samsung. It's brilliant.
It really is. And to see just how confident TSMC is in the longevity of this loop, you only have to look at their capital expenditure forecasts. For 2026, TSMC expects their capex to reach between $52 billion and $56 billion in a single year.
That is a staggering commitment. I mean, companies do not deploy $56 billion on factories and infrastructure unless they possess ironclad, long-term guarantees from their customers that the demand is permanent.
Exactly. A $56 billion capex isn't just a corporate budget, it functions as a global macroeconomic forecast. It serves as undeniable proof that the physical build-out phase of the AI revolution is still expanding.
The hyperscalers are still expanding their data center footprints.
Right. The infrastructure layer is nowhere near saturation.
So the tech giants are selling the enterprise market a vision of an AI automated future. And TSMC is selling the physical capacity that allows that vision to exist.
Yeah.
But, controlling the modern world's most critical resource is incredibly lucrative. But doing it from a single, strategically sensitive island creates terrifying geopolitical tension.
It really does. This raises an important question about global reliance. Even as the world begs for diversification, it remains completely dependent on this Taiwanese manufacturing engine. Advanced semiconductors have shed their status as mere commercial goods.
Oh, absolutely. The United States, Japan, and the European Union now classify cutting-edge chips as critical national security infrastructure.
Yeah, the realization that a single geopolitical disruption in the Taiwan Strait could halt the production of smartphones, medical equipment, automotive systems, and advanced defense platforms, it has triggered a total global panic to onshore manufacturing.
Which is why the United States is currently executing a massive push to bring TSMC's capabilities to American soil. The Arizona expansion has evolved into a staggering $165 billion plan.
Right.
That includes 6 fabs, 2 advanced packaging facilities, and a dedicated R&D center.
Yeah, and politicians frequently point to these Arizona fabs as the ultimate solution to supply chain vulnerability. But there is a massive difference between exporting machinery and exporting an industrial ecosystem.
Exactly. You can load an ASML lithography machine onto a customized cargo plane, fly to Phoenix, and plug it into the grid. You cannot air freight the localized, highly integrated culture of Hsinchu, Taiwan.
It's impossible. A world-class fab relies on a deeply embedded supplier network. In Taiwan, if a specialized chemical pipe bursts or a unique gas mixture needs adjustment, the supplier is literally a 15-minute drive down the road.
Right.
And specialized engineers are on call 24/7 to resolve the issue instantly.
Whereas in Arizona, that same supplier might be located states away or simply might not exist at the same scale. The Taiwanese engineering culture is defined by relentless optimization, rigorous shift work, and decades of institutional knowledge passed down through the local workforce.
Yep. Replicating the physical concrete and the clean rooms is just a matter of capital. Replicating the invisible 1,000-step daily process improvements embedded in the workforce culture takes a generation.
So what does this all mean for the security of your everyday tech? I mean, it's pretty ironic that the world's most cutting-edge digital technology is entirely bottlenecked by physical geography and local workforce culture.
It really is.
Yeah.
And while international fabs in Arizona, Japan, or Germany will eventually provide a baseline level of global resilience for older nodes, Taiwan will remain the bleeding edge of TSMC's efficiency and technological supremacy for the foreseeable future.
The gravitational pull of that localized ecosystem is simply too strong to replicate quickly.
And the global reliance on that Taiwanese ecosystem is about to expand drastically.
Right, because we have to look to the future beyond just chatbots. Right now, the public associates AI primarily with cloud-based text generators and image creators. You type a prompt into your laptop, it pings a massive server farm in Virginia, and the data center sends the answer back.
But the industry is rapidly transitioning toward physical AI.
Yes, physical AI.
Which represents the integration of intelligence into the tangible world. Autonomous vehicles navigating chaotic urban environments in real time. Humanoid robotics executing complex tasks in manufacturing or logistics. Smart industrial automation. Advanced aerospace systems.
And vitally, edge AI, which involves running complex neural networks directly on your smartphone, laptop, or local device without relying on a constant latency-heavy connection to a cloud server.
And every single one of those physical AI applications requires an entirely new class of hardware. They need hyper-efficient, compact, incredibly reliable chips that can process massive amounts of data while drawing minimal battery power.
And here's the kicker. If the entire AI industry remains centralized in massive cloud data centers, TSMC manufactures the server chips, and they win.
Yep.
If AI transitions to the edge and lives inside the phone in your pocket, TSMC manufactures the mobile chips, and they win. If AI becomes embedded in the autonomous car in your driveway, TSMC manufactures the automotive silicon, and they win.
They are entirely agnostic to the software wars. They don't need to bet on whether a specific robotics startup or a legacy automaker wins the physical AI race. They are the foundational supplier to the entire category.
Right.
They have essentially engineered a scenario where the advancement of human computation is managed through a capacity-rationed economy.
A capacity-rationed economy. I love that term. Because instead of an open market where innovation scales infinitely, the ceiling of global technological progress is physically capped by the number of wafers TSMC can produce in a given quarter.
Exactly. The ultimate victor in the current AI landscape isn't necessarily the engineering team that develops the most elegant code. The winner is the corporation with the capital and the leverage to secure a factory slot in Taiwan before their rivals do.
Just as oil shaped the 20th century industrial economy, compute will shape the 21st century intelligence economy. During the 20th century, the geopolitical and industrial order was fundamentally organized around access to petroleum. Oil dictated national security strategies, catalyzed massive infrastructure investments, and established global corporate hierarchies.
And in the 21st century, computational power serves that exact same structural role. An advanced economy simply cannot function without continuous access to high-performance silicon. The most powerful AI company isn't the one with the smartest model, it's the one that decides who gets the silicon to run it.
Exactly. The raw material of the new intelligence economy is being physically forged layer by atomic layer behind a highly guarded toll bridge. If you want to participate in the next decade of technological evolution, you have to pay the toll and you have to wait for the gate to lift.
Yeah.
Which leads us with a critical, lingering question to consider as we close out today's deep analysis.
Let's hear it.
If access to the most powerful computational hardware in human history is being aggressively rationed like a finite natural resource, What happens to the innovators operating outside the massive tech monopoly?
That's a great question.
What happens to the brilliant, scrappy startups, or the universities, or even entire developing nations who simply get priced out of the AI revolution because they cannot afford the multi-million-dollar ticket to secure TSMC's manufacturing capacity?
Yeah.
Will the future of global intelligence be democratized by software, or will it be permanently gated by who has the capital to access a factory floor in Taiwan?
It's a structural imbalance that will define the trajectory of the global economy for the next 20 years. The physical reality of manufacturing will always dictate the limits of our digital ambitions.
The friction between the limitless potential of software and the brutal constraints of physics. Thank you for joining us for today's deep analysis. Keep looking past the software interfaces to question the physical infrastructure running the world, and we will catch you on the next one.